What function is its own derivative? So finally, the real answer to the question, what function is its own derivative, we're talking in the normal real case here, is e to the x and only e to the x.
Ah, so close and yet so far. Because of course, there's not just one function that satisfies that differential equation, there are infinitely many solutions. And that's of course because if the exponential function's derivative is itself, then any constant multiple of the exponential function will also be its own derivative. And well, you might say that those are just basically the same thing as the exponential function. And while you might be right, there is definitely a choice of the constant that gives you something that looks essentially different. Namely, when k is 0, you get that the 0 function is its own derivative. And that sort of definitely feels different than the exponential functions. Oh, I just broke my piece of chalk in two. Anyway, since the OP was talking about Taylor series, let's see how using Taylor series we get that the solutions to this are all the multiples of an exponential function. So this form of a Taylor series, if we plug it in here, then we get this equality of Taylor series. So now we compare coefficients. So this equality of Taylor series implies that the k plus 1th coefficient is the kth coefficient divided by k plus 1, which in turn implies that the kth coefficient is the 0th coefficient divided by k factorial, which in turn implies that the function we were looking for is a constant multiple of this Taylor series, which is the Taylor series for the exponential function. So every solution is a constant multiple of an exponential. Now, something that is non-trivial is the fact that you have to prove that a function whose derivative is itself converges to its Taylor series in its domain. And that is something that one needs to prove using Taylor's remainder theorem, for example, but that's something that needs to be checked before we can use Taylor series to say what function is this. So anyway, maybe I can do that in some other TikTok.